Hi guys, this is 5.2b lesson, and we have already done the first page, so we're going to go ahead and skip right to the second page. Go ahead and take out your notes for 5.2b and follow along during this video. So this first one says the following table shows the relationship between the amount of cherries in pounds and the cost. Is the relationship proportional? How do you know? So go ahead and pause, take a minute to decide, is this relationship proportional? And why or why not. So when I'm looking at this, I see that from the amount of pounds, I need to multiply by 150 to get the amount of pounds. And I need to check that it works every single time. So 5 times 150 also equals 750. So every single time I can multiply by 150. So I can say, yes, each number I'm going to say each number of pounds can be multiplied by 150 to get the corresponding cost. The next one, is the weight dependent on the cost, or is the cost dependent on the weight? So what depends on what? And I think about this as we're going to buy fruit at the store. How much we pay depends on how much that fruit weighs. So the cost, or the dollars, are dependent on the weight, right? The weight of the cherries does not depend on how much we pay. It's the cost depends on the dollars. Put the information from the table on the graph below with the amount of cherries in pounds on the x-axis and the cost in dollars on the y-axis. So that means I need to label my cost in dollars here. Oh, actually it already did it for us. So cost in dollars is on the y-axis and amount of pounds in cherries is on the x-axis. The x-axis is always going to be the independent variable and the y-axis is always going to be the dependent variable. So now I'm going to use my data from up here to graph this. And because the x is the amount of pounds and the cost is y, I like to actually write these as coordinate points. So 1, 150, 2, 3, 3, 450, 4, 6, and then 5, 750. So now I can plot these points. So the first is 1, 150, then go over to 2 and up to 3. Go over to 3 in the amount of pounds and then up to 450. Go over to 4 in the amount of pounds and then up to 6. And then go over to 5 in the amount of pounds and up to 750. And this can actually still have another point plotted. It could keep going. And we know that if we bought 0 pounds of cherries, we pay $0. So we kind of need to extend our graph all the way from the origin to continue going, right? We can't buy negative amounts of cherries, so that's why I erased that part of it. Examine the graph. What conclusions can you make? Well, it's just asking you to describe the graph. So you can describe this in your own words. We can recognize that this is a line. We can describe where it starts. So I'm going to say the graph is linear, or a straight line. Linear just means it's a straight line. And it starts at the origin, or 0, 0. Next question, what point on the graph describes or represents the unit rate? Well, if we look back at our table and see where the unit rate is, The unit rate is always one of the values is 1. So the point on our graph would be 1/150, or this point right here. So that point is 1 pound, cost $1.50. Now complete the graph for the table below. Be sure to label your axis with words. Draw a straight line through the points if you can. So we have number of MP3s and we have the price. And we have to think what's going to depend on what. So in this case, our price, or how much we pay, is going to depend on how many MP3s we buy. So we can actually already answer B. The dependent variable is the price, and the independent variable is the number of MP3s. That means that the independent goes on the x-axis, number of MP3s, and the price goes on the y-axis. Now I can plot these points. So the first point is 1 and then 2. So, or actually, I'm reading this backwards. This is why I need to write my coordinate points. So the first point is actually 2 MP3s for $1. So I can go out to 2 and then up to 1. The second point is actually 3 MP3s for $1.50. So 3 and then 150 is going to be about right there. The next point is 4 and then 175. So over to 4 and then up to 175 would be right there, or just under 180. 5 and then 190 would be just under 2. 6 and then $2. And then 10 and $5. So it says, are the number of MP3s and price proportionally related in this situation? How do you know? So if I were to continue to graph this, this is not going to have some kind of constant rate, right? So no, there is no constant value that relates MP3s to the price, right? Examine the graph. What conclusions can you make? Well, this graph looks a little bit different than our other graph because it is no longer a straight line. So this is not a straight line. And we're actually going to skip 3 and go on to question number 4. So the day after Thanksgiving, Games R Us charges an entrance fee of $5. This is kind of like a flat rate of $5. And then $2 per hour for unlimited play. Complete the table and graph to represent this situation. Be sure to label the axis of your graph with words. Draw a straight line through the points if you can. So time and cost. Remember what I said about time? When we have time, time is always going to be independent and cost is always going to be dependent, which means time, I like to change it to X and cost to Y. So this is our cost in dollars, and this is our time in hours. So after 0 hours, be careful on this one, how much would we pay? We have to go back and read the problem. It says this charges an entrance fee of $5. So even just to get in, if I didn't even play any games, I have to pay $5 just to get in. Then after 1 hour, it's $5 plus that $2 per hour. So this is a total of $7. Then after 2 hours, I would have had to pay that $5 plus $2 each hour. So that would be a total of $9. And if you'll notice, what's happening here is I'm just adding $2 each time. So after 3 hours, I'd pay 11. After 4, I'd pay 13. And after 5, I would pay 15. Now my graph is going to look a little bit different because it does not start at 0, 0. It now starts at 0, 5, right? If we're going to do coordinate points here, this would be 0, 5, 1, 7, 2, 9, and so forth. So our next point would be 1, 7, 2, 9, 3, 11, 4, 13, and 5, 15. If you'll notice, it's just going up $2 for every 1 hour. $2 for every 1 hour. Are cost and time proportionally related in this situation? How do you know? Okay, well, this is a straight line, but I need to remember that a proportional relationship, I should be able to multiply or divide by the same thing every time to get from my x value to my y value. From 1 to 7, I would multiply by 3. From 2 to 9, I would multiply by 4.5. From 5 to 15, I'd multiply by 3. Those are all already different. So I can say, no, there is no constant of proportionality. Or you cannot multiply by the same thing each time to get the corresponding value. So state the independent and dependent variables. We kind of already did this up top. Our independent variable would be time, and our dependent variable would be cost. It says examine the graph, what conclusions can you make? So something that it's really going to come later in the module, but notice how our graph does not start at 0, 0. That is representative of a non-proportional relationship. So I'm going to say the graph does not start at 0, 0 or the origin, but it is a straight line. Okay, so this next part here says in math, we often make conjectures after observing something. For example, if you observe that your math teacher wore a geeky math teacher shirt every day for the first week of school, you might make a conjecture that your math teacher will wear geeky t-shirts the second week of school. A conjecture is a conclusion based on observations, similar to an educated guess that you then have to justify or explain. So it says, make a conjecture about how to determine if a table of values represents a proportional situation. So how to determine if a table of values represents a proportional relationship. This is really important because this is how you're going to tell on a test or a quiz, is this a proportional relationship in this table of values? So if we think back to all the tables that were proportional in this lesson, every single time to get from my x to my y, I could multiply by the same number. So that's what I'm going to say here. So if you can multiply each x value or independent value by the same number each time to get each y value, it is proportional. And this next one, make a conjecture about how to determine if a graph of values represents a proportional relationship. So if we think back to all the graphs that we did, every time we could multiply the x's by the same number to get the y, we also could graph, and our graph could pass through that 0, 0 point. If we look back at the one we just did, this graph does not pass through 0, 0, and it was not proportional. So for the graph, I'm going to say proportional relationships are linear or straight lines that pass through the origin, or the point 0, 0. And that's actually where we're going to end today. We're going to finish up the rest of this lesson and 5.1c in class, next class. If you guys wanted to go ahead and get started on your 5.1b homework, you probably could do that. It's already going to be posted in Google Classroom this afternoon.